Hello today. This is Lorenzo. I wanted to make a video. This is something that just came up, but I wanted to make a video on why using plywood is not the ideal choice for building loudspeakers. I recently had an issue today, just a small little issue or incident where I decided to make this video. I actually had someone. So to start first off. If the video is not set up correctly or if the microphone doesn't sound clear, I'm not the camera guy. He's not here today, so I don't have no camera guy today. I had to set up everything myself. So I got the external microphone placed on my left side here, and I got the camera all set up. So if it's not correct, if the camera's not set up correct, or if the audio is not that clear, it's my fault, and I apologize for it. But I just wanted to make a short video, just to demonstrate the difference between MDF board and plywood. As you may have noticed, that there are a lot of manufacturers out there today. When it comes to building commercial grade loudspeakers or professional loudspeakers, they use plywood. And it's not, after working with plywood, I have been building speakers out of MDF for well over almost 20 years, but recently decided to design a loudspeaker using plywood. But the problem with plywood is there are a couple of things, but the reason why you see a lot of manufacturers that are manufacturing, commercial speakers out of plywood is simply because of the weight. It's just, plywood is just, it's really light wood. It's not heavy and it's not as dense as MDF. If you were to take like a commercial loudspeaker, like a pro speaker, like a small screen speaker using a 10-inch driver in a 1 cubic foot size cabinet or even a cubic foot and a half, that speaker out of MDF would weigh around, give or take about at least 60 pounds, at least 50 to 60 pounds. But if that same speaker cabinet was made out of plywood, it would probably weigh about 35 to 40 pounds. Not even 40. I would say about 30 to 35 pounds. So this is why you see a lot of manufacturing these big pro speakers, because you have to remember, professional loudspeakers are very huge and large. Probably the smallest one, they usually go around about 24 inches tall or 2 feet tall up to 5 feet tall. And when you have speakers that size using that raw building material such as MDF, that speaker is going to weigh easily over 100 pounds. And a lot of these commercial setups, they like mounting the speakers on the walls, just like surround speakers at a movie theater. You see speakers mounted on the wall. Well, those speakers, when you start mounting speakers that weigh anywhere from 100 pounds up to 120 pounds, it gets very heavy, and you have to make sure the speakers are clearly, mounted well. Make sure the brackets are really sturdy and mounted well. That's a very heavy speaker to be mounting on a wall. Not only that, but just to lug around a speaker that size. And this is why you see a lot of manufacturers using plywood, because it's just lighter, and it's, I guess, when it comes to assembling cabinets, it's more easier to assemble because how plywood work is just basically the cabinets are usually bolted together. You could bolt a cabinet together just with regular drywall screws or just regular anchor screws to assemble the cabinet. But unlike MDF, it's a whole nother process. And I've run a couple of boards just to show the difference between them. For example, let's see. Now this is just a regular sheet of 2 by 2 feet plywood. And again, this is why I'm making this video, because I actually had an individual actually told this person to get me a sheet of MDF, a 2 by 2 sheet of MDF. So that they actually brought me back this, and this was actually plywood. It was not fiberboard or MDF. So at first I was a little upset, but I after a while, it didn't really matter, I understand this person made a mistake because they're actually not a speaker builder, or they don't work for us. But I just told the individual just to get me, specifically MDF, because I wanted to fix a cabinet that was actually made out of laminated vinyl and plywood, but I wanted, not plywood, but particle board with laminate vinyl. But I wanted just MDF because it was faster and quicker to make a cabinet door for, instead of using this plywood. But they brought me this, so this is why I made the video. But anyways, you know, one reason it's not good to manufacture a speaker out of plywood, you know, as you look at it, you know, it's really light. I mean, that's the only advantage I would see from it, is that it's very light. It's not as dense as fiberboard, but as you look, and this is just a regular sheet, it's not even sanded, and as you can see, you know, plywood is actually, as you can see the grain right here, it's actually laminated sheets, or they call it, the professional term is plies. They actually take plies of sheets, of very thin sheets of wood, which they call plies, and they, you know, glue them together with adhesive. And this is how you get the name plywood. They use either 7 plies or 4. It depends on the thickness of the wood. And this is a 1/2 inch thick, but 3/4 inch plywood actually usually use, I guess, 7 plies, which means 7 sheets, or 7 very thin veneer sheets of wood. And they glue and press them together, press them together, and they get this. And the problem with this is that the wood is not really dense at all when you're comparing it to MDF. Even though this plywood may be slightly more expensive, and it gets even more expensive if you buy the sanded sheets. That's actually, I think, you can actually buy a sanded sheet, which is maybe like 20% or 30% more than a regular sheet that's not sanded. You know, one of the main purposes of the cabinet, you want the cabinet to be very dense and solid. You know, weight, you know, is one thing. Yes, the weight of the loudspeaker does affect the sound quality. It does. It just does, you know. But you want the cabinet just to be solid, where it's very low resonance and it doesn't vibrate. Try to remember, I actually measured these 2 sheets, and this, I did not put the scale on here right now because I measured them earlier, but I didn't put the scale because the scale was very small and the sheets was too big for the scale. But I did weigh them, and I'm trying to remember the size. I mean the weight. The size is 2 by 2 1/2 inch thick, and this piece right here weighed 5 pounds and 1 ounces, just over 5 pounds and 1 ounce. And when you look at it, you know, it doesn't really feel like so much like 5 pounds, but I weighed it, and it's 5 pounds and 1 ounce. Now you take this other sheet that I have right here, which is MDF, and right here, this actually weighs a whopping 9 pounds and like 1.4 ounces. So this is close to 10 pounds just for this sheet, and it's a lot heavier. But this is, you know, not your ordinary grade of MDF sheet. This is actually a layered sheet. This is layers of MDF glued together. I actually took 2 layers of MDF board, and it was glued together using very strong adhesive, commercial grade adhesive. And this was just a sample I did. As you can see, and you can see it's 2 boards that I glued together with very strong adhesive, and it's just rock solid. Again, you know, this is MDF. This is very dense. As you can see, the material is very solid. You know, it's not coarse, and you don't see the pores inside the wood. It's totally dense. And the more dense the material is, you know, the less that you're going to see, you know, less coarse that it is. And this weighs 9 pounds compared to the plywood, which only weighs 5 pounds, and it's the same thickness, same size. And this is not even a treated sheet of our MDF that we use. You know, now we use treated MDF, which basically is like a 72-hour process that we use to make our cabinets more rigid and more durable. And by using that treated process to our MDF cabinets, it just makes the cabinet, more rigid, more solid, but it adds weight to it. You could take a cabinet that weighs around, like we have a small MDF cabinet that could weigh around 15 pounds, and we would treat that cabinet, and the treating process would add 5 pounds of weight to the cabinet. So the cabinet would go from 15 pounds to 20 pounds. And you can see, I'm just checking the camera to make sure everything is recording. Okay, it's still recording. I'm not the camera guy, so I'm trying to set up everything. Hopefully it's set up correctly. But as I was saying, you go from 15 pounds to 20 pounds using a treated cabinet process. And we don't do this to all our speakers, only to our selected or higher end loudspeakers that we do it to. Like, for example, our reference mini monitor 115, which was the first speaker to have this treated process. I don't have it with me at the moment, but again, I'm just talking about the wood. So, we're using fiberboard that is more dense. You get just, better sound quality in the bass department, And it makes the cabinet more solid, more rigid. So it helps really balance the bass response. And it really helps control the balance of the bass response when you have it in a very rigid and tight cabinet. Unlike, this plywood, a lot of manufacturers use it because it's just the weight, it's just lightweight. Like, a cabinet that would normally weigh like 50 pounds, as I said earlier, 50 pounds out of MDF, you make it out of plywood, the same cabinet, you're going to get around 30 pounds. And it really makes it different because when you deal with commercial loudspeaker, you are using drivers that have very big magnets that weigh anywhere from 7 to 10 pounds. And then when you add that to a cabinet that already weighs 50 pounds, you add another 10 pounds for the magnet, another 5 pounds for the basket of the driver. And then you add the compression driver, which has a large magnet as well for the high frequency response. You could easily, 50, 65, 70, you get about 75 pounds with the crossover. And the crossovers have to be really large coils to handle the, anywhere from 300 to 500 watts. So you're looking around anywhere from 75 to 80 pounds for a loudspeaker with the drivers in a cabinet that weighs 50 pounds. So, but when you make that same, so if you have a cabinet with the speakers in it that weighs 75 pounds, you can make that same cabinet out of this stuff, the plywood, and it's going to cut the weight down considerably. It would just cut it all the way down to around about 40-45 pounds. A lot better than 75 pounds. So, but ideally, it's just, plywood is good for doing construction when you're building cabinets, like for kitchens and stuff, because when it gets wet, nothing really happened to it. It absorbs water, but it doesn't damage the wood like MDF does. You could take MDF here, and if it gets wet, it will deteriorate. It will get really soft, and it will just swell double its size if it gets wet. But with plywood, it doesn't, and this is why a lot of construction workers use this for cabinets in kitchens for that reason. They use it as a subfloor, or they just use it to build underneath the counters of the cabinets, of the countertops, because it's easy to drill through, screw through, because it's just really thin sheets of wood, which is very not dense at all, just very light and very thin. But like for example, this is just a regular drywall screw, and you could screw through this easily because it's plywood. You could just take a compact drill, cordless drill, and just drill straight through it with this screw. You don't have to drill a pilot hole, and the screw would go straight through the wood with no problem. Real easy. It doesn't take much torque to do it. But if you were to take the same screw and put it through a sheet of MDF like this, it's not going to be as easy. It's going to be very hard to do. You have to apply a lot of pressure. Not only pressure, but you have to make sure that it goes in correctly and straight, because this stuff, it's not hard to drill through, but when you're trying to screw through it, you can't do it because it would damage the wood, you know, because it's so dense. The wood would just slightly bubble, and then you wouldn't get a good holding grip from it. So what you do is basically you have to pilot each hole. You have to drill pre-holes, pilot holes into each part that you want to screw, and then screw in. And because it's very dense material, you know, it's soft material, but it's very dense. You know, it's the ideal material for building, you know, basic loudspeakers. But again, you know, we use this material, but we add a treated process, and this process makes the outside of the cabinet very hard. It makes it more durable, but it also just adds weight. And a kind of small example would be this speaker. Now this is SMT7 loudspeaker. It's a satellite speaker, and it's made. The whole cabinet is entirely made of MDF. As you can see, it's a very compact cabinet, very a little tall, but very narrow. It's only 6 inches wide, about 15.5 inches high. As you see, it's very compact, and it's made out of 3.25 inch thick MDF. Yeah, it's made out of this stuff, but just more thick. Very heavy, very solid, and well built. And again, you know, this is ideal for building loudspeakers. You know, there's other materials, of course, more expensive materials that will perform, you know, just as well, maybe even better. But on a standpoint, you know, acoustically, MDF is still, you know, a great choice. It's the main choice by a lot of manufacturers, you know, because there's so much stuff that you can do to it, you know, MDF, that you can't do to other building materials. But again, you know, the plywood is just a material I think is it's good for construction, but for designing loudspeakers, you know, you have to really think about it, because it's just for us, you know, it just requires a lot of sanding. You know, there's a lot of knots here that you see in the wood, some cracks and splits in the wood. So that has to be all sanded down, especially if you are not going to cover this speaker in a vinyl. You're going to have to do a lot of sanding. Then you have to fill in all these little gaps and these knots that's in here. Then you have to reset it again, and then reset it till it's perfectly smooth, and then, you know, prime it, paint it, or whatever that you do to give it a finish. And it's very time consuming. The only advantage, like I say, is the weight. It's very light, and it's easy to screw into, build into. But you know, it's just really a lot of work, a lot of process, and you'll get a lot of flex in your loudspeaker cabinets. When the drivers compress the air back and forth in the cabinet is going to vibrate, it's going to resonate slightly, because this material is not really dense. So the sound quality is going to be slightly different. You may sacrifice a little bit of sound quality if speakers are built out of this material. And this is why we use, even for our professional speakers, which we started designing about 3 years ago, going to be 3 years ago. You know, we make them all out of MDF. All our pro speakers, you know, commercial grade loudspeakers are made out of this material, MDF. You know, and the reason why we can make them out of MDF, for the simple fact, is that they are on a smaller scale. They are not, you know, a large scale like a lot of professional speakers that you will see. For example, this is one of our very first professional loudspeakers. This is an AT, actually it's a AT24 speaker, and you can see the whole cabinet is made out of MDF. You know, it's very heavy. There's a lot of process that we do to our MDF cabinets, to our more higher end loudspeakers. And see, what else do I have? You know, this is a typical 3/4 inch MDF board. You know, see, it's a lot thicker, just a 1/4 inch thicker than the 1/2 inch. This is 1/2 inch, 3/4. And you know, most all loudspeakers are made out of this material, because again, you know, even our small speakers such as this one, we use the same building material, and the cabinets are just heavy and rock solid. And plus, these are not treated actually, but we do have ones that are treated, and they are just heavy for their size. And see, is there anything else I wanted to mention about the material? So basically, you know, there are advantages using different types of building material. But, you know, again, you know, we just like to use MDF for that reason. Because we are able to just really do a lot with it. You know, we could shape it to what the shape that we want. We could treat the cabinet and make it harder. So we get better performance out of our speaker cabinets. And it's just a building material that's really, you know, for us, easy to work with. And not only that, but we use, you know, we're thinking about using plastics in the future, polymers, and of course, you know, metal, aluminum. You know, we've been thinking about making, you know, manufacturing, you know, part of our speaker cabinets out of aluminum too. But right now we're doing the MDF because, you know, we've been doing MDF for a very long time. So we know, you know, we know how to take advantage of it. We can do things, you know, with MDF that's not normally done, that people normally don't do, but we do it with MDF. Of course, there's hardwoods, of course, you know, and we have built speakers, you know, a lot of demo speakers out of hardwood. So there's a lot of advantages and disadvantages there with hardwood as well. But right now we just choose to use MDF. Maybe in the future we use hardwoods. And hardwoods is just a whole nother story, you know. And it does affect the speakers acoustically, you know, depending on the type of wood. I mean, there's many hardwoods that you could buy that is just as hard as very hardwood. Because we know we could just, you know, we know how to really use it and treat the cabinets to make them, you know, perform much better. So I think that's about it. So we'll probably be posting more information about, you know, the weight of the cabinets and on our Facebook page. You know, you can always find us at facebook.com/MODVO, MODVO at Facebook. And also to mention that a lot of our adhesives that we use, you know, inside these cabinets, you know, a lot of our newer speakers, it's actually acoustic adhesive. You know, it's designed to reduce resonance, and it will improve the clarity of the speaker itself, the sound from it that comes from it. It will actually makes the sound more deadener. It's a special composite that we use, you know, to dampen the inside of our speakers. We actually use 2 dampers, matter of fact, on one of our speakers. And one is a dampening, you know, compound, and it helps reduce vibration, basically. That's all it does. But we also have a type of compound epoxy, which is designed for acoustics, basically. And that's what it's specially designed for. And it really deadens the sound of the cabinet. It makes the joints of the cabinet more solid, because that's the weakest point of the cabinet, is the joints. So, but when we use this acoustic compound and adhesive, it just helps, you know, helps really lock the joints of the cabinet together. It helps reduce the resonance of our speakers. So I think that's about it. I don't know if it's anything else that I have missed on this. But again, you know, I just made this video. It was supposed to be a short video, but it actually came out longer than I intended it to be. But I just wanted to make, you know, just to show, you know, the difference between plywood and MDF, you know, when it comes to building loudspeakers. You know, there's disadvantages and disadvantages, but you know, this is why we choose to use MDF. And like I say, in the future we may use you know, metals and polymers, plastics in the future, but for right now it's MDF. So this just came out to be a long video, but I hope you liked the video, and I'll be back next time. Thank you.